Okay, decide if each of the equations is true or false. Explain your reasoning. Look at the first one. Is there any number that I can plug in here to make this equation true? Okay, so let's try to solve this one. Okay, so when we solve, we want to get x by itself, right? Okay, so we're going to multiply x on both sides. And so that's going to give me x plus 7 on this side equals 7x. What am I going to do now? Say again? Not divide by 7. Subtract that x, right? So 7 minus 1 is going to give me 6x equals 7. Now what am I going to do? Divide. So I'm going to divide by 6 on both sides. So x would have to equal 7, 6. That's the only way to make this equation true, right? So I could say true, and it would be x equals 7, 6. Okay, on the second one, is there any number that I can plug in to make this equation true? 1 would work. Okay, would 2 work? Yeah. Would 3 work? Any number would work. So this is true always, right? Okay. So we're going to be simplifying these two problems. Simplify each rational expression to its lowest terms, specifying the values of x that must be excluded. What does the word excluded mean?
Leave out.
Okay, leave out. To be rejected, right? To avoid division by 0. Okay. All right. So looking at this first one, what can you take out in the top and the bottom? You can take out an x squared, okay? And the reason why is because we have 5 x's in the top and 2 x's in the bottom. How many can we take from each thing? 2 x's. What are we left with in the top? X to the third, right? Now, what about the numbers? 7 and 21. Both of them can be divided by 7. So if we divide by 7 in the top, we're going to get 1. If we divide by 7 in the bottom, that's a percent sign. We're going to get 3, right? This would be our simplified form. So on here, we've got an x minus 1 in the bottom, and then we got this x minus 1 squared in the top. Is there anything that we can cancel? Okay, so we're going to cancel x minus 1 here and x minus 1 here. But when we cancel this x minus 1 in the top, we're only going to get rid of one of them. So really, we're just going to decrease the exponent to 1. Okay, so here it is again. If you have 2 of something in the top and then 1 of something in the bottom, you can only cancel it 1 time. Okay, is there anything else that'll cancel in here? No. Okay, so we're just going to rewrite what's left over. So we got x times x plus 3 times x minus 1 divided by x minus 5. Here's the new part, the excluded values. Excluded values are going to be anything that's in the denominator or anything that you canceled out. So that's going to be like your wholes and your vertical asymptotes, right? So x cannot be 5 nor 1. So remember, excluded values are going to be your vertical asymptotes or wholes. You got to state those at the end. This is a negative. If we took 5 and we plugged it back into this equation, look at what the denominator would be. Well, we have 5 minus 5. What is that going to give us? 0. And if we divide anything by 0, that's going to be undefined. And that's a big no-no in math, right? So we cannot have our wholes or our vertical asymptotes be a number that we plug into this. Yeah. Ta-da. Okay, let's go ahead. Yes, Cleveland. Somebody raise their hand. Okay, go ahead and write down these two problems. So on the first one, we're going to factor in the top and the bottom. Okay, you need to get comfortable with factoring or you will fail. Okay, so in the top, we're going to factor. A times C is going to give us -16 and B is going to give us 0. What two numbers can I multiply together to give me -16 but add together to give me 0? Can you multiply 8, -8? Yeah, there you go. Okay, so this can be written out as x plus 4 times x minus 4. In the bottom, we're going to factor. A times C is going to give us -8. B is going to give us 2. What two numbers can we multiply together to give me -8, but add together to get me 2? Or -2. So x plus 4 and x minus 2. Okay, you need to be comfortable with factoring. If you're not, you've got so much work to do. Not stress you out. Okay. Is there anything that we can cancel on the top and the bottom? Okay, so that x plus 4s. Okay, we're left with x minus 4 over x minus 2. And we're going to say x cannot equal what thing? Okay, so 4 and, I'm sorry, no. Change the sign, -4. And then, there you go. The ones that you cancel out, the ones that are left in the denominator. So vertical asymptotes and wholes. Yeah. Okay, I'll give you a second. Okay, on the next one, it gets a little bit trickier. We've got to have to factor by grouping in the top. Okay, so throw back the factor by grouping. Remember, we put parentheses around the first and around the second. What can I take out from this first group? Okay, and then I'm left with x plus 3. Over here, can I take anything out? No. Okay, you're actually going to change these numbers. I'm sorry, because this doesn't work otherwise. Change this number, this original problem, to x plus 3. I apologize. I know, it's okay. Be mad. Okay. And you're left with x plus 3 once you factor. Okay. Wow. So what you're going to do now is, since these repeat, you're going to drop 1. And then you're going to push those two things together. So you'll get x squared plus 1. And then x plus 3 in the top. Now we have to factor what's in the bottom. Okay. So is there anything I can take out from this denominator? Just an x, right? And we're left with x squared plus 2x plus 1. Can I factor this stuff? Well, let's try. A times C is going to give us 1. B is 2. What two numbers will multiply to get that? 1 and... Good try. 1 and 1. Okay, so that's going to give me x times x plus 1 times x plus 1. Okay, so we got x times x plus 1 times x plus 1. All right. Can we cancel anything out? Nope.
No, you can't.
No, you can't. Okay, because this says x squared plus 1. The whole thing isn't squared, just x squared plus 1. And can you break this down anymore? No. Okay, so what we're going to do is we write this out as our answer, and then we say x cannot equal, and what can it not equal? -1. And okay, so we take anything that's in the denominator. Somebody said it. 0. Because of the x. There you go. That's our final answer. Probably a good idea. So go back to like 4th grade, maybe 6th. This might have been 6th grade. Okay, so when you were doing these, there was two different ways that you could do. So you multiply across, that's fine. Or you could do this. Break 20 down into factors. Like 4 and 5, right? Break 9 down into factors. 3 and 3. Is there something that repeats in the top and the bottom? Okay, what I mean by that is I have a 5 down here, and then I got a 5 up here, right? And then I got a 3 over here, and I got a 3 over here. So now all I'm gonna do is everything that's left over, I'm gonna write it out. 4/3. You know, and probably most of you did do, okay, is you multiply straight across. You went 3 times 20 is 60, and then 5 times 9 is, and then you said, what's the greatest common factor that I can take out, which is 15, and I gave you 4/3. All right, what? That would have given you 100 and then 27.
No. Yeah, 0 or 5.
Okay. You can do it that way. I think. Yeah. Okay. Let's see if it works on the next one. Okay, so on the next one, your teacher was like, okay, when you're dividing fractions, you're gonna do the KFC, but not KFC, keep, change, flip way, right? Okay, so that's gonna be 2/5 times, because we're gonna change the sign, and then we're gonna flip our chicken. Okay? Yep, flip the chicken. Okay? And then you either multiply it straight across, or you could do it where you break down by factors. I'm gonna show you that way again. 15 is gonna break down into 5 and 3. Okay, and 4 is gonna break down into 2 and 2. I can cancel out 2 in the top, 2 in the bottom, 5 in the top, 5 in the bottom. I'm left with 3/2. Yes, you did. Okay, so on this one, it's gonna be kind of similar to what we just did. But it's more the way that I did it than what you did. Okay, so what I mean by this is, you see that there's a 3 up here in the top. Can we break this 21 down into 7 and 3? So what happens is those 3's cancel, right? Okay. Over here, we got a 4x squared and then a 4x to the third. So you can take out a 4x squared, right? So these 4's cancel, and then you can take out the x squared, and you're left over with an x. So what is left? Oh, x over 7. You got to be really careful with, is it in the top? Is it in the bottom? Is it being multiplied? Okay, so you got to pay attention to that. Got to be organized. Okay. So same thing's going to happen on the next one. This one's a little bit easier to see. We've got an x plus 4 in the top and x plus 4 in the bottom. So those guys can cancel. We got an x plus 3 in the top and an x plus 3 in the bottom. Those will cancel. And what am I left with? 5x minus 6 over 3x plus 1. Okay, the one thing that we haven't done though is we have not stated the excluded values. Okay, so on here, anything that we canceled out, we've got to say, hey, it can't equal that. So it can't equal -4, it can't equal -3, and it cannot equal this 3x plus 1. And if we solve that, that's going to give us -1/3. So if we took that 3x plus 1, and we set it equal to 0, and we solved. Yes, because that's in the denominator. Then it would give us x equals -1/3. So this entire thing is our answer. Okay, let's talk about this last one. I'm gonna bring this guy up here so that you can actually like see it. Okay. What we've got to do is we've got to factor first. Okay, so we're gonna factor this top part. So when we do that, we're gonna get a times c, which is -4, b, which is -3. What two numbers can I multiply together to get me -4, but add together to get me -3?
Not one.
Okay, all right, now, since a is bigger than 1, we're gonna divide both of these guys by that 2. If it gives us a whole number, we're just gonna bring it down. So -4 divided by 2 is gonna give me -2. And then 1 divided by 2 is going to give me 1/2. That's not a whole number. So I'm gonna do the slip and slide. I'm gonna bring the 2 up to the top and push that 1 over. Okay, so that's the top of this first fraction. The bottom, is there anything I can take out of these? Not 3, just 3. Okay, so I can take out a 3. So this is gonna give me 3 times x minus 2. I'm left with 6x over here. Can't do anything with that yet. Can I factor anything with this guy? Not x. Let's try the big X method though. Okay. A times c is gonna give me -4. B is going to give me 0. What two numbers will make that happen?
-4 and 4.
Oh. Good try though. Good try. Okay. Since A is bigger than 1, we're going to take this and divide it. Okay. -2 divided by 4 is going to give us a fraction. But can we reduce this fraction? Yeah, what is it going to be? -1/2. So we're going to do the slip and slide method, and that's going to give us 2x plus 1 and 2x minus 1. Okay. This would also simplify to 1/2, and that's why I got that plus. Now, is there anything that repeats in the top and the bottom? 2x plus 1. Is there anything else? Okay. And then do you see this 6 and this 3? Well, what's 6 divided by 3? Okay, so let's go ahead and cancel that and leave it with 2. So let's rewrite what we have left over. 2x divided by 2x minus 1. And then we've got to state our excluded values. So we're going to say x cannot equal, and what can it not equal? +2. It cannot equal 1/2 nor -1/2. Okay, so sometimes these problems can be really simple, and then sometimes these problems can be really long. Okay, on this first one, we see that division is in the middle. So we are going to do the keep, change, flip method. So we're going to keep the first fraction, change the sign to multiplication, and flip that second fraction. Flip the chicken. Flip the chicken. Okay. Now, once we have done that, now we are going to factor. Okay, so that way we can figure out if we can cancel anything out. Okay, can we factor anything over here on this first fraction? Why not, Logan? Well, we can't break out a greatest common factor. Like we can't take anything out. This has nothing that it's paired with, right? And this m plus 5, we can't take out an m because it's attached to +5, right? Okay. Over here, can we factor this guy? Yes. Okay, so we're gonna do the big X. We get 25 in the top, and in the bottom, what two numbers will multiply to give? Okay, so this will give me m plus 5 times m plus 5. On the bottom, can we take out anything from this? M, and we're left with m plus 5. Okay, can we cancel anything? M plus 5s. Okay, can we cancel anything else? There's an m squared here and an m. Take an m out, right? So that's left with one m. So that'll be m is our final answer. What do we need to include?
Minus 5.
Okay, so we need to say x or n. Sorry.
The m.
Yes, ma'am.
At the bottom, the m squared and then the m plus 5. You took out the m, right?
I took out these m plus 5s.
And then
So I did m plus 5, m plus 5. Those canceled. M plus 5 and m plus 5 canceled. And then I said m squared and m cancels, but I'm left with an m up here. Okay. Now we're going to state our excluded values. So we're going to say m cannot equal -5 or 0.
wait, can you actually say like what it is?
Last problem. Looks crazy, right? It looks nuts. Let me break it down for you. This first fraction up here, we're going to write it down. And then it says divided by, so we're going to say divided by. And then we got this second fraction. Isn't that the same thing that we got going on up here? Yeah, so we do the same process. We keep the first fraction. We change the sign and we flip the second fraction.
And you changing the way you feel, right?
Just let me live my life.
It makes it worse.
I'm changing like one font to another. Just let me live. Okay, so now we're going to factor. Okay, so over here, we can take out an x. In the bottom, if we factor this, we're going to get x minus 4 times x minus 4. Over here, we're going to get 2 times x minus 4. And then we're going to get 12 in the bottom. Can you finish this problem from here? So you should have gotten cancel, 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 cancel. You're left with 2x divided by 12. Can that 12 and that 2 simplify?
Yeah.
To be x over 6. Okay. And what can x not equal? 4. That's it. Well, we wouldn't set it equal to 12. It would just be what x cannot equal. Yeah. Okay.